I remember the exact moment I understood what the James Webb Space Telescope had actually found. I was reading a statement from a Nobel Prize-winning physicist, a man who has spent his entire career measuring the universe, and he said this: "With measurement errors negated, what remains is the real and exciting possibility that we have misunderstood the universe." That stopped me completely. Not a science fiction writer, not a YouTube channel, a Nobel laureate writing in an official NASA publication saying that we may have misunderstood the universe. I want to tell you what he was responding to. Because what the James Webb Telescope has found in its first 3 years of operation is not just impressive images. It is a series of discoveries that our best models of how the universe works simply cannot explain. And I think when you understand exactly what those discoveries are, not the version designed to make you click, but the real version, you will feel the same thing I felt. A kind of awe. And under the awe, something that feels almost like vertigo. Let me start with the telescope itself, because you need to understand what makes it different from anything we had before. The Hubble Space Telescope sees in visible light. Webb sees in infrared. That matters for 2 reasons. First, infrared light passes through dust clouds that would completely block visible light. Second, light from the very early universe has been redshifted all the way into infrared. Webb's mirror is 6.5 meters across. Webb collects roughly 6 times more light. It is stationed 1.5 million kilometers from Earth, kept at an extraordinary cold. It launched on Christmas Day 2021. By the summer of 2022, the first science images arrived. And almost immediately, something was wrong. Wrong in the most interesting possible way. For decades, cosmologists have worked with what they call the standard model of cosmology, the Lambda-CDM model. It is the most precisely tested model in the history of science. This model tells us how galaxies should form and grow. In the first few 100 million years, the universe should have been thin, sparse, a place of slowly gathering gas. Galaxies should have grown slowly. Webb looked at that era and found something else. Fully formed, massive galaxies, already present 500 million years after the Big Bang. Mike Boylan-Colchin, an associate professor at the University of Texas, examined 6 of these galaxy candidates. He said, "If the masses are right, then we are in uncharted territory. For a galaxy to grow that massive that quickly, it would need to be converting nearly 100% of its available gas into stars. Our models allow a maximum of about 10%. Now, I want to be careful here because science requires care. Some astronomers have proposed that the mass estimates may be too high. That is the right response. That is science working as it should. The second discovery is what I find personally the most unsettling. Since the 1920s, we have known the universe is expanding. And for decades, astronomers have been trying to pin down exactly how fast. The first method looks at the early universe, the cosmic microwave background, mapped by the Planck satellite. From those measurements, you can calculate what the expansion rate should be today. The second method measures the expansion directly, using the cosmic distance ladder. At the foundation are pulsating stars called Cepheid variables. Comparing their true luminosity gives you their distance. The problem is that the 2 numbers disagree. The difference is about 9%. For years, one explanation was that the direct measurements had some subtle error built in. Webb was supposed to check that. Adam Riess used Webb to observe over 1,000 Cepheid variable stars. The results, published in February 2024, confirmed the measurements completely. There was no hidden error. Riess said it plainly. "We can rule out a measurement error as the cause with very high confidence." He added, "What remains is the real and exciting possibility that we have misunderstood the universe." Nobody knows what causes the tension. Leading possibilities include a form of dark energy that behaved differently, exotic particles, or a modification to our understanding of gravity. The question remains open. The third thing Webb found is about black holes. Before Webb, we thought supermassive black holes grew slowly alongside their host galaxies over billions of years. That was the model. Webb pointed at the early universe and found supermassive black holes already in place just 500 to 800 million years after the Big Bang. The numbers do not work. A 2025 study examined a galaxy called Virgil. Webb revealed a supermassive black hole so large the researchers described it as overmassive. It challenges every model we have. A separate discovery looked at galaxy GN-Z11 shining just 430 million years after the Big Bang. Webb detected an actively feeding black hole and a cloud of pure hydrogen and helium. The possible explanations: either black holes form through direct collapse of enormous gas clouds, or our understanding of growth is fundamentally incomplete. Both require physics we do not yet have. I want to say something honest before I close. None of what I have described proves that the standard model is wrong. When observations challenge a model, the first response is to look for errors. The challenge is genuine. The Hubble tension has been confirmed, and the early massive galaxies and overmassive black holes keep appearing. The scientists are not dismissing this. They are genuinely uncertain. The history of physics is full of anomalies that turned out to be something completely new. Dark energy came out of measurements that did not fit. Unexplained noise became evidence for the Big Bang. We do not know yet which kind of anomaly this is. We pointed a telescope at the oldest light in the universe, and it did not fully match what we expected. That is not a failure. It is an invitation. I am not a medical professional. Everything I have shared is my personal experience of reading research from NASA, ESA, and major journals. Subscribe and leave a comment. What is the one thing about the universe you find hardest to hold in your mind?